Okay, welcome to section 3-7 examples. This is about solving system of equations by graphing. So first of all, we need to talk about what systems of equations are. So you can go ahead and read this, but I'm just going to explain it myself. We have one equation here, y equals 4x, and another equation where y equals 4x plus 2. That is called a system of equations. And whenever we have two equations like this, we can always solve the system of equations and see if we can get a solution. We'll always get some sort of a solution, and we'll go through the three different types of solutions we can get later on. So let's move down here and see what that means in a sample problem. So in example number 1 here, they are asking you to solve this system of equations. We've got y equals negative 2x minus 3, and we have y equals 2x plus 5, and they want us to solve it by graphing. So the first thing we're going to do is we're going to graph this equation. So we have a y-intercept here of negative 3, so we put a point here at negative 3. As you can see, it's already done for you. And then also we can take a look at the slope here and recognize that we could drop 2 and over 1, get another point here. Now, one of the things that you can always remember is that if you run out of room going this way on the graph, you can always do the opposite. Instead of dropping 2 and going right 1, I can go left 1 and go up 2, and I'm still creating points on the graph. So once you get these in a row, you can kind of see that this right here is our line. As I said, this has already been done for you, but I want to show you how they got those numbers. So now let's take a look at the other equation. We have a y-intercept of 5, and our slope is 2 over 1. So we would go up 2 over 1, but we can't do that, so we'll go down 2 and left 1, down 2 more and left 1, and you can see that this would be that line. So now let's back this off so that we can see what that does for us. We have an intersection of the two lines right here, and as it says here, it appears. Now you can't really be absolutely sure just by graphing a line, because instead of negative 2, that could be negative 2.01, and we would never know it without actually calculating it. So we really need to double check that. But it appears that our solution is negative 2 on the x-axis and positive 1 on the y. So our coordinate would be negative 2, 1. So the next step is to take our solution and plug it into the original equations. So we take negative 2 and put it in for x here and here in our original equations, and positive 1 and plug it in for y here and here. So as you can see, we have 1. Does that equal negative 2 times negative 2? Well, negative 2 times negative 2 is positive 4. Positive 4 minus 3 is indeed 1. We have a solution for this equation. So then we go over here and we try, we're asking, is 1 equal to 2 times negative 2 is negative 4 plus 5. Negative 4 plus 5, of course, is 1. We have a solution there. So indeed, our answer, our solution to these two equations, the intersection of these two lines, is negative 2, positive 1. Please press pause and do letters A and B. So now let's go to sample number 2. Gregory's Motorsports has motorcycles, 2 wheels, and ATVs, 4 wheels, in stock. The store has a total of 45 vehicles that together have 130 wheels. Write a system of equations that represent the situation. Well, the first thing you want to take a look at is let's let y represent motorcycles, like they said, and then let's let x represent the ATVs, or the 4-wheelers. Okay, so we can say that the motorcycles, y, plus the ATVs, x, will result in 45 vehicles. In other words, what I would like you to start to think about when you do this type of thing, do things like this, where you put motorcycles plus ATVs equal vehicles. I can't quite fit it here, but you get the point. So then once you say that, it's kind of hard just to tell that this is a plus sign here. once you make that statement, then it becomes obvious that you're going to use some variable for motorcycles, in this case y, and you're going to add the variable for ATVs, and you're going to get the vehicles, which the problem told you is 45. Try to put these situations, the words, in a mathematical statement. Motorcycles plus ATVs equals total vehicles, and then the numbers and the actual equation should follow quite easily. Let's take a look at the other one. The other thing we know is that we have 130 wheels. And of course we know that motorcycles, y, have 2 wheels. And we know that ATVs, x, have 4 wheels. So we could say that motorcycle wheels plus ATV wheels equals total wheels. Notice I didn't even really have to write that all out. So now we can take a look at that. How would we figure out how many wheels for the motorcycles? Well, obviously it's 2 times motorcycles, or 2y. And how many for the ATVs? It's 4 times the number of ATVs. Add that all up, and how many wheels should we have? 130. So that's where those 2 equations came from. The next thing we are asked to do is to solve that system of equations. And then, of course, we have to interpret the solution. So we have this equation here, x plus y equals 45, and we have 2y plus 4x equals 130. But I want you to notice that all of a sudden we have an equation that looks very different, and I want you to see where they came from, because it asks you to write it in slope-intercept form. And in a minute you'll understand exactly why we want to quickly turn this into slope-intercept form. The other thing that we could do here is we could just put zeros in for the x and the y and get the x and the y-intercept to graph this, but this is probably the easiest way. So we started out with x plus y equals 45, and we want that into y equals mx plus b. So we have the y on this side, but we need to move the x over to here. And of course you know very well that the way to get rid of x is to subtract x. So subtract x from both sides. This is a 0 pair. We end up with the equation exactly like we want it. Y equals negative x. Remember, we want to put the x value first, plus a 45. Now we have a slope of -1 right here, and a y-intercept of 45. And that's what we're going to use this equation for. So now let me show you how they did this other one. 2y plus 4x equals 130. First step is the same. We need to get the x to the other side, so we're going to subtract 4x from both sides. Remember, I talked the other day in class about some kids will get to realize that all you have to do is move the 4x over to the other side and it becomes -4x. But let's go through the steps here to make sure everybody understands. That's a 0 pair. We're going to have 2y equals -4x and then plus the 130. Remember, that's the format we wanted, in with the x first. But we don't have it in the y equals some amount of x plus or minus some constant format, the y equals mx plus b, because we have 2y. So clearly we need to divide this by 2. But now this is the big thing that a lot of students will make an error here. They'll just divide one of these by 2. You can't. There's 3 terms here. There's this term here, this term here, and this term here. You must divide all terms by 2. So divide this by 2 and this by 2, we get y equals -4 divided by 2 is -2, and of course we have the x. We're going to add 130 divided by 2 is 65. So there's our other equation. So those are the 2 equations we're going to use. So we're going to plot this point here. We have a y-intercept of 45. We put our point there. Now notice our scale here is changing by 5, and also down here it's changing by 5, which is a plus. So the next thing we're going to do is we're going to drop 1 and over 1, because this of course is -1/1 for a slope. So because we're dropping 5 and over 5, we can just continue to go right through each of the intersections here, and we then end up down here then at 45 as well. For the other equation, we're going to start at 65. Now notice that's not even actually showing on this graph, which is really a huge problem. In my opinion, they should definitely show that. But let's say we had the y-intercept of 65 up here, and then we're going to drop 2 and over 1. Now because our units are the same here, we're changing by 5 here and changing by 5 here, we can use those, as students often call them, boxes, these little square here, because it's 5 units and 5 units, we can drop down 10 units and over 5 units, and that is that dropping of 2 and over 1. So from any given point, like right here, we're going to drop 2 and over 1, drop 2 and over 1, and draw the second line. Now once we have those lines, of course, then you're going to notice that we have a solution here. And it looks as though our solution is our x value would be 20 and our y value would be 25. So our point is 20, 25. So keep that in mind, and we will move down below and check it. So we're going to put 20 in for x, 25 in for y, 20 in for x here, 25 in for y here. Do the math, and we have 20 plus 25 equals 45. That one's a check. And we do the math here. We have 2 times 25 is 50, plus 4 times 20 is 80, and 50 plus 80 is indeed 130. We have a check there. Our solution works. Please press pause and do letter C. Okay, this is a very important concept that I want you to put in your notes. It's about number of solutions. And what we're talking about here is that when we solve systems of equations, we can end up with one of 3 different situations. If the lines intersect, in other words, we have a system like this where we have a system of equations, there's one line, here's the other, right there's our one solution, we will have one solution. If the lines are parallel, well, you can just imagine if you had 2 parallel lines, they're never going to intersect. There is no common value, therefore there is no solution. No solution. And then lastly, if the lines are the same, in other words, one line is here and the next line is right over the top of it, there are an infinite number of solutions. Literally any number that you put into either equation is a solution to the system of equations. Number 4, solve each system of equations by graphing. So in this case, we're going to graph y equals 2x plus 1. So we put a point at 1 right here, and then we go up 2 over 1, and we end up with this line right here. And then if we go to y equals 2x minus 3, we put a point at negative 3, and we go up 2 over 1 a couple of times, and we draw our line. Clearly they have the same slope, therefore they are parallel lines. Let me say that again. Look at it. You should have seen it right here. They have the same slope. The same slope means the lines have the same slant, the same tilt. Therefore, they're never going to intersect, and we have 0 solution. So there is no solution for this system. And looking at the graphs tells us that. However, we can also look at that in a little bit different way. We can analyze that situation. And the way to analyze the situation is to remember what standard form means. We can write each of these in standard form, where you have the y value plus or minus the x value equals some constant. So that means we'd like to move the x over to this side. And remember, we can move the x to this side and basically it becomes negative. We subtract 2x from both sides. I can barely fit that here. And we have y equals negative 2x minus 1. If we do the same thing here, move the 2x over to this side, it becomes negative right here, and we have y minus 2x equals negative 3. Well, the algebraic solution to the fact there is no solution to this equation is this right here. If you say that y minus 2x and y minus 2x are the same thing, how can the same thing be both 1 and negative 3 at the same time? It makes no sense. There is no solution. And that's what you're going to put for this. Whenever they are parallel lines, you're going to put no solution. Wouldn't hurt to put this on your gold sheet, those words, so we use the proper terms. How about now in problem number 5? We have these 2 equations. We start out with our equation, y minus 3 equals 2x minus 2. And like it says, we're going to write that in slope-intercept form. So the thing we want to do is add 3 to both sides, and we have our equation of a line here. The idea is to graph those 2 equations. So if we graph y equals 2x plus 1, we put a point at 1, and we have a slope of up 2 over 1, and we draw our line. Then if we graph this line here, we just turned this equation into a slope-intercept form of y equals 2x plus 1. It is the same line. So no matter what, any ordered pair you put on the graph, it will satisfy both equations. So there are an infinite number of solutions to this system of equations. The line is the same. This is just another way of saying this mathematically. Please press pause and do letters D and E. Okay, problem number 6. A system of equations consists of two lines. One line passes through the points 2, 3, and 0, 5. The other line passes through the points 1, 1, and 0, negative 1. They're asking you to determine if the system has no solution, one solution, or an infinite number of solutions. So the first thing we can do is we need to write an equation of each of those two lines. And we're going to do that in slope-intercept form. The first thing we want to do is find the slope of each of those two lines. So let's clear a little bit here. Let's take the first two and find the slope. So we're going to use 5 minus 3 right here over, that's the change in y, over the change in x is 0 minus 2. 5 minus 3 is 2. 0 minus 2 is negative 2, so that would be a slope of negative 1. The next thing we're going to do is do negative 1 minus 1 and 0 minus 1. Negative 1 minus 1 is negative 2 over 0 minus 1 is negative 1. A negative over a negative becomes a positive, so our slope there is positive 2. And then find the y-intercept for each line. So we have slope of negative 1 and slope of 2. Find the y-intercept for each line. Well, use the point 0, 5. So our intercept is 5, so b becomes 5. Our slope is negative 1, so that becomes negative 1 here, and we have an equation y equals negative 1x, or we could just write negative x plus 5. Over here, we also have a point of 0, negative 1, so our y-intercept is negative 1. It's right here, and our slope is 2 right there, so we have y equals 2x minus 1. Now, here's our two equations, y equals negative 1x plus 5, and y equals 2x minus 1. Since the lines have different slopes and different y-intercepts, they must intersect at exactly one point. So now we're going to graph each on a coordinate plane. So we're going to start at positive 5 right here for this equation, and we're going to drop 1 and over 1, and we get this line right here. And then we're going to start at negative 1 right here. Negative 1 is our point right there, and we're going to go up 2, over 2, up 2, over 2, up 2, over 2. Let's say that the second point would be right there. We're going to draw a line right through there. So we have a solution that looks to be right here, which is 2, 3. So we're going to graph each line on the coordinate plane, just did that. The lines intersect at 2, 3. There is exactly one solution. One thing I want to point out here is that originally we showed you that you should put these numbers in the equations in order to show definitely that that is a point. And another thing you can think about is, in this case, this one here, we started at 5 and we dropped 1 and over 1. So if we go down 1, over 1, down 1, over 1, we end up exactly at that point. In this case, we started at negative 1. We're right here at negative 1, and we go up 2 over 2 for the slope, up 2 over 1, up 2 over 1. Again, we end up exactly at that point. That is a pretty good indicator that this is indeed an exact solution to that equation. Keep that in mind when you are graphing them. Our next lesson will show you how to calculate these things algebraically, which is the best proof. Please press pause and do letter F.